Welcome to Outbreak Brief, the podcast that takes you inside the world's most dangerous infections.
Yeah. And today, we're diving into something truly terrifying.
Right. Today, we're taking you into the crosshairs of one of the deadliest hemorrhagic fevers known to science. We are looking at a microscopic assassin, one that, hides in the dark, silent corners of bat caves and possesses just a terrifying fatality rate.
It really is. It's a true biological thriller.
Exactly. It's a thriller-style exploration of a pathogen that literally turns the human body against itself. So get ready. We are talking about the Marburg virus.
Yeah. And to really understand this virus, we have to go back in time a bit.
Right. I want to transport you to August 1967. Picture the setting. It's post-war Europe. Medical science is booming, and we're in these sterile, highly controlled, state-of-the-art medical laboratories in Marburg and Frankfurt, Germany, and also in Belgrade, Yugoslavia.
So everything is incredibly clinical. Bright lights, smelling of bleach, right?
Exactly. Total progress and order. The lab technicians are there processing tissue samples from African green monkeys that were recently imported from Uganda. It's totally routine work. They're spinning blood in centrifuges, preparing cell cultures, and then, without any warning, that pristine environment just completely shatters.
Yeah, because the workers processing those tissues, they start falling ill. And this isn't, a slow creeping onset.
Right. It hits them like a freight train.
Exactly. They're experiencing these violently high fevers. Within days, their bodies just begin to break down in ways that left these highly seasoned modern doctors completely baffled.
I mean, we are talking severe gastrointestinal distress, rapid organ failure, and inexplicable spontaneous bleeding from their mucous membranes.
Yeah. 31 people were infected almost simultaneously across those different locations, and 7 of them died rapidly. It's just absolute medical terror.
7 dead,
Yeah.
just out of nowhere in these top-tier European facilities.
Oh, the global health community was paralyzed by it. I mean, This wasn't a known tropical disease that had somehow migrated. When researchers finally isolated the pathogen that was killing these technicians, they realized they were looking at a brand new top-tier biological threat.
What we would now call a Group 4 pathogen.
Right. And it was manifesting right in the middle of modern Europe. Because the monkeys were the immediate source, the press and early medical reports just dubbed it green monkey disease.
Okay, let's unpack this. If we're dealing with something that can turn a world-class European laboratory into a fatal hot zone, we have to look at the biology. We know it now as the Marburg virus, or MARV. When scientists finally got this thing under an electron microscope, what exactly were they staring at?
Well, they saw something that looked like a long, tangled thread.
Or like a shepherd's crook, right?
Yeah, exactly. That curved shape at the end. Marburg belongs to a family called filoviruses. So it's a single-stranded, negative-sense RNA virus.
Making it an incredibly close cousin to Ebola.
Very close. It shares that same bizarre, worm-like structure. But what makes Marburg so uniquely devastating isn't just how it looks, it's how it operates once it breaches our physical barriers.
Right, and I really want to focus on that breach because the mechanics here are terrifying. My understanding is that the virus doesn't just, overpower the immune system by sheer force. It actively sabotages the communication lines.
That is the defining characteristic of Marburg. When it enters your bloodstream, it immediately seeks out the very cells designed to protect you, your frontline immune sentinels.
Like the monocytes, the macrophages, and dendritic cells.
Exactly. Now, normally when a virus enters a cell, that cell releases a distress signal called interferon. It's basically a chemical flare.
Warning the rest of the immune system that an invader is present.
Right, and that triggers a massive defensive response. But Marburg carries specific viral proteins, specifically ones we call VP35 and VP24. And these proteins actively suppress the host's interferon response. They block that signal from ever getting out.
Okay, so it's basically like a highly coordinated burglar. Before it even breaks into the house, it cuts the alarm wires, the interferon, so the immune system doesn't even know it's being robbed.
That is a perfect analogy. And while it's doing that, its glycoprotein acts like a master key, binding to the Niemann-Pick-C1 cholesterol transporter to slip inside the host cells undetected.
So the rest of the immune system is just patrolling the neighborhood, completely unaware of the home invasion.
Exactly. And by the time the body realizes there's a breach, the virus hasn't just replicated aggressively. It's actually using those infected immune cells as the taxi service.
Yeah.
The macrophages carry the virus through the lymphatic system directly into the liver, the spleen, the lymph nodes.
Wow. It uses our own defenders against us. But wait, if this thing is so perfectly evolved to evade our immune system, where has it been hiding? The African green monkeys in that 1967 lab couldn't have been the true natural reservoir, right? They were dying from it just like the humans.
Right, the monkeys were just middlemen. They were innocent bystanders, really. It took scientists decades of ecological sleuthing to find the true source. The natural reservoir is actually the Egyptian fruit bat.
Ah, the Rosetus aegyptiacus.
Yes. These bats live in massive colonies inside caves and mines across sub-Saharan Africa. And the evolutionary twist here is that the bats can carry Marburg, they replicate it, they shed it, but they don't get sick.
They're just the perfect silent hosts.
Completely.
Yeah.
And when we stumble into their environments, the results are catastrophic. Let me walk you through the 1998 to 2000 outbreak in Durba, in the Democratic Republic of the Congo.
That was the mining cluster, right?
Yeah. This outbreak mostly affected young gold miners working deep inside the Gorumbwa cave. I mean, imagine the environment there. It's pitch black, sweltering heat, terrible ventilation.
And the ceiling is just completely blanketed with Egyptian fruit bats.
Thousands of them. The miners were working in there for hours a day, breathing in aerosolized bat guano, coming into direct contact with bad secretions. And out of 154 cases in that outbreak, 128 people died.
Oh, wow.
Yeah, that's an 83% fatality rate. It just decimated those young men.
But even that wasn't the largest one we've seen. Just a few years later, from 2004 to 2005, Marburg exploded in Uige province in Angola. And this wasn't just isolated to miners in a single cave. It swept through communities, pediatric wards.
It was devastating. There were 374 cases and 329 deaths.
That's an astounding 88% fatality rate. But we went from 1967 in Germany to miners in the Congo decades later to an entire province in Angola. What triggers these sudden explosions of the virus? I mean, how does it tear through people who have never set foot in a bat cave?
Well, the initial infection always requires that zoonotic jump, right?
Yeah.
Prolonged exposure in a mine or touching bat droppings or contact with an intermediate animal like a monkey or possibly a pig.
Right, the spillover event.
Exactly.
Yeah.
But once Marburg is inside a human host, its strategy shifts. It adapts to human transmission.
Yeah.
The mechanism for this spread is direct physical contact with infected bodily fluids.
So we are talking about blood, sweat, saliva, vomit, feces, breast milk, semen.
Yes, all of the above. If any of those infected fluids touch broken skin, even a tiny microscopic cut, or if they make contact with mucous membranes like your eyes, nose, or mouth, the virus transfers.
I think we need to make a very clear distinction here for anyone listening. People might be picturing a horror movie where someone coughs on a subway and infects the whole car. Marburg is not an airborne respiratory virus like the flu, right?
No, absolutely not. You cannot catch Marburg simply by breathing the same air as an infected person in a normal setting. The only rare exception is in hospitals during specific aerosol-generating procedures, like intubation.
Right, that's highly dangerous for the doctors.
Very. But otherwise, it requires tangible fluid transfer. The real danger, though, is that Marburg survives extremely well on surfaces. A contaminated bedsheet, clothing, an unsterilized needle, those can remain highly infectious for days.
Okay, let's talk about the timeline of contagion because that plays a massive role. If I am exposed to the virus today, what happens tomorrow?
Tomorrow, you will likely feel completely fine. The incubation period for Marburg is anywhere from 2 to 21 days, though it averages around 5 to 10 days.
And here's the crucial point for the listener. During this incubation period, you are not contagious, right?
Correct. That is a massive epidemiological detail. You cannot spread Marburg to your family while the virus is silently replicating inside you. You only start shedding the virus and spreading it once symptoms appear.
And because of that specific bodily fluid transmission route, Marburg creates this tragic paradox. It literally weaponizes human compassion and care.
It does. The vulnerable populations are consistently the caregivers. It's the mother nursing her sick child, the spouse changing contaminated bedding, and of course the frontline healthcare workers lacking proper PPE.
They are primarily in the crosshairs. And biologically, certain groups face much worse outcomes, right? Like pregnant women.
Oh, pregnant women face horrific risks. Spontaneous abortion, incredibly severe disease progression. Older adults also suffer higher mortality.
And geographically, we're talking about rural populations in sub-Saharan Africa being the most at risk.
Yeah, because they live closest to the bat's natural habitat. And that risk is compounded by socioeconomic factors, delayed diagnosis, limited healthcare infrastructure.
We also have to mention the cultural factors. Traditional burial ceremonies are profoundly dangerous with Marburg.
They really are. In many cultures, mourning involves touching, washing, and preparing the body of the deceased. But when someone dies of Marburg, Viral shedding continues even after death. The viral load is at its peak.
So mourners interacting with the body without gloves are inadvertently turning a ceremony into a super spreader event.
Exactly.
Okay, here's where it gets really interesting and honestly visceral. Knowing who is infected, what exactly does the timeline of this nightmare look and feel like for the patient?
Well, the onset is violently sudden. Days 1 through 4 are what we call the generalization phase. You go from feeling perfectly fine to having a fever of 39 or 40 degrees Celsius, around 104 Fahrenheit, severe chill, splitting headache, muscle aches.
It sounds like a really aggressive flu at first.
It does, which makes early diagnosis tricky. But the patient rapidly becomes debilitated. By day 3, we see severe watery diarrhea, abdominal cramping, and severe vomiting.
Patients look like ghosts at this point, right?
Yeah, deep exhaustion, sunken eyes, expressionless faces.
Yeah.
Then we hit days 5 through 7, the early organ phase. This is when a non-itchy maculopapular rash appears.
And this is when the hemorrhagic signs begin, the real horror of the disease.
Right. Patients begin bleeding from their gums, their nose, their eyes. Anywhere a needle was inserted, there's blood in their vomit and their stool.
Okay, I want to step in here. Can you explain the biology of why that bleeding happens? Because the virus isn't just chewing holes in the veins, right?
No, it's a condition called disseminated intravascular coagulation, or DIC. Remember how we said the virus blocks the early immune alarm? Well, once the body finally recognizes the massive viral load, it completely panics. Systemic inflammation triggers massive abnormal blood clotting all throughout the body.
Right, so it's forming thousands of these microscopic clots in the blood vessels, which uses up all the body's internal clotting factors.
Exactly.
It's like a city using up every single sandbag it has to patch a bunch of tiny puddles, and then a massive hurricane hits. When a real leak happens, there's absolutely nothing left to stop it.
That's a great way to picture it. The clotting factors are depleted. So paradoxically, this massive clotting event leads to severe, unstoppable bleeding.
Yeah.
The patient bleeds because their body just can no longer patch the microscopic tears in the capillaries.
Wow. And then days 8 and 9, the late phase.
Yeah, that's when the neurological symptoms take over. Confusion, seizures, coma. In fatal cases, death typically occurs right here, usually preceded by massive blood loss and systemic shock.
With a pathogen this aggressive, how can modern medicine possibly fight back? Let's talk about treatment.
The reality is tough. There are currently no fully approved specific antiviral drugs for Marburg virus.
But the silver lining here is that basic supportive care is actually incredibly effective.
It is a game changer. We rely on aggressive IV fluids, electrolyte replacement, supplemental oxygen, and blood transfusions.
And that can drastically change the outcome. I mean, fatality rates can swing from 88% all the way down to 24% just based on the quality of early supportive care.
Absolutely. Keeping the body hydrated and oxygenated buys the immune system enough time to mount a counterattack.
But scientists aren't just relying on IV fluids for the future. What are the experimental therapies looking like?
There's a really active pipeline. Antivirals like galidesivir, favipiravir, and remdesivir are being studied. But the really exciting work is with monoclonal antibodies, things like MR186 and MR191.
Wait, those are generated from the B cells of Marburg survivors, right?
Right. So you're essentially giving a sick patient the immune blueprint of someone who already fought the virus and won.
That's incredible. But treating the sick is one thing. Can we shield the healthy? Are there vaccines available?
Well, no vaccine is fully proved for Marburg yet. But the 2013 Ebola epidemic really accelerated all filovirus research. Candidate vaccines like K83, Marburg, and Valbea are showing a lot of promise in trials.
Okay, but what about immunity after infection? I read something about Marburg and immune-privileged sites, and it is chilling.
It's one of the most insidious things about filoviruses. Marburg can physically hide in areas of the human body where the immune system is naturally restricted, like the inside of the eye, or the central nervous system, or the testicles.
Wait, so even after you survive and you clear the virus from your blood, it can just hide out in your eyes or your testes like a sleeper agent?
Yes. The immune system's hunter-killer cells aren't allowed to patrol those areas to prevent severe inflammation that could cause blindness or sterility.
Yeah.
So the virus just retreats there and persists. In that 1967 outbreak, there was a case where the virus was sexually transmitted via semen 203 days after the man's initial infection.
203 days, that's nearly 7 months later. Wow.
Yeah, viral persistence is a huge challenge.
So since vaccines aren't totally ready and treatments are mostly supportive or experimental, our main weapon is really behavioral defense, right?
Exactly. It's public health warfare. Boots on the ground interventions. When an outbreak hits, you need rapid contact tracing, strict quarantine, active surveillance, and safe, modified burial practices.
And for the hospitals and individuals.
For hospitals, it requires BSL-4 isolation when possible. Extreme PPE for healthcare workers, gowns, masks, face shields, goggles, double gloves, no exposed skin. And locally, avoiding bushmeat and bat habitats is critical.
So, with these protocols in our arsenal, where does the war against Marburg stand right at this moment? Let's talk about the current situation as of May 2026.
Well, Marburg consistently tests our defenses. In recent years, we've seen outbreaks in Ghana in 2022, Tanzania and Equatorial Guinea in 2023, and then there was a really concerning outbreak in Kigali, Rwanda in 2024.
Right, the Rwanda outbreak had 66 cases and 15 deaths. Many of them were healthcare workers, which really shows the occupational risk. But that ended in December 2024. What about right now?
As of January 2026, Ethiopia's Ministry of Health reported an active outbreak in the South and Sidama regions. We are currently looking at 14 laboratory-confirmed illnesses and 9 deaths.
And the CDC and WHO are actively monitoring that, right?
Yes, they have teams deployed, helping with contact tracing and surveillance. It's a serious situation on the ground, but it's important to emphasize that currently, the risk of Marburg outside that specific region, like in the U.S., remains very low.
As we track these real-time outbreaks, we have to look ahead. What is coming next? What are scientists racing to discover?
There are major unknowns. Biologists are trying to figure out if there are other bat species harboring the virus. And a huge concern is domestic agriculture. We know domestic pigs can act as amplification hosts for filoviruses.
Oh, wow. So if Marburg jumps from a bat to a commercial pig farm.
Exactly. The sheer volume of viral replication could drive massive, uncontrollable cross-species jumps into the human population.
So what does this all mean for you, the listener? When you look at the entire story of Marburg, from a sterile laboratory in Germany to gold miners in the Congo to hospitals in Rwanda and now communities in Ethiopia, a clear pattern emerges.
It really does.
Marburg isn't actively hunting humans. We are stumbling into its territory. As deforestation, mining, and human expansion push us deeper into the habitats of the Egyptian fruit bat, we are eroding the natural boundaries that kept these pathogens isolated. We aren't just facing a medical problem anymore. We are facing an ecological one.
Absolutely. Every time we carve out a new mine or clear a forest, we're rolling the dice.
Are the next great pandemics not mutating in a high-tech lab, but simply waiting for us in the dark of a cave?
It's something we all need to be thinking about.
Stay informed, stay prepared. This has been Outbreak Brief.